Find the point or points where the tangent line for x squared minus 2xy plus 4y plus y squared equals 32 is A, horizontal, and B, vertical. A horizontal line has the slope of 0. A vertical line has the slope of positive or negative infinity. We want the slope of the tangent line, which is the derivative, to be these two things. So we will find the derivative of the given equation, x squared minus 2xy plus 4y plus y squared equals to 32. This is an implicit equation because we do not have y solved in terms of x, so we will have to take the derivative implicitly. This is done by taking the derivative of both sides with respect to x, indicated by a prime on both sides. On the left side, the first term, x squared, will be a power rule. Bring the power down, subtract 1 from it. Second term is a product rule of negative 2x times y. The derivative of the first, negative 2 times the second left alone, y, plus the first left alone, negative 2x, times the derivative of the second. The derivative of y is 1 times y prime. Every time we take the derivative of a y term, we will have a y prime due to the chain rule. The derivative of the third term, 4y, will be the constant 4, but then times y prime because we just took the derivative of a y term. The derivative of the fourth term, y squared, will be a power rule. Bring down the power, subtract 1 from it, and then multiply by the derivative of the inside, which will give us a y prime due to the chain rule. Equals to the derivative of 32, which is 0. There are three terms that have a y prime on the left side. I will want to isolate the y prime terms on one side of the equal sign. Since two of the three are positive, I'm going to keep them on the left side, and I'm therefore going to move the other two terms that do not have a y prime over to the right side. That will leave us with a negative 2x y prime plus 4y prime plus 2y y prime equals to, I'm going to add the 2y over and subtract the 2x over. I can now factor a y prime out on the left side, leaving a negative 2x plus 4 plus 2y. And now I can solve for y prime by dividing both sides by what's inside the parentheses on the left side. And y prime will be 2y minus 2x over negative 2x plus 4 plus 2y. Since the coefficients of all the terms in the numerator and denominator are even, I can factor a 2 out of the numerator and denominator. Factoring a 2 out of the numerator will give us a y minus x. In the denominator will give us a negative x plus 2 plus y, and those 2's can cancel. So the derivative y prime, which is the slope of the tangent line, is equal to y minus x over, and it's customary to write the positive term first, so I will move the positive y to the front, and then the negative x, and then the plus 2. For part A, we want to find where the tangent line is horizontal. So we want the slope of the tangent line, which is the derivative, to equal to 0. For the derivative to equal to 0, we need its numerator down here to equal 0. So we will want y minus x to equal 0. Adding x to both sides, that gives us that y equals x. To find the point or points, this can be plugged into the original equation over here. X squared minus 2xy plus 4y plus y squared equals to 32. Each of those y's can be replaced with an x, giving us x squared minus 2x times x plus 4x plus x squared equals to 32. So we have x squared, a minus 2x times an x is a minus 2x squared, plus 4x plus x squared equals 32. We have three terms that have an x squared, a positive 1, a negative 2, and another positive 1. 1 minus 2 is negative 1, plus 1 more 1 is 0, so they fully cancel. So we can cancel each of those out, leaving us with a 4x equals to 32, or an x equals to 8. We're under the condition that y equals x here, and therefore if x equals 8, y also equals 8, and we have the point of the x-coordinate 8, comma the y-coordinate 8. So there's the point where the tangent line is horizontal. Now let's look where the tangent line may be vertical. We now want the slope, which is the derivative, to be positive or negative infinity. This occurs when the denominator, down here, is equal to 0. So we want y minus x plus 2 to equal 0. We can add x to both sides, and that will give us y plus 2 equals x. It's possible to subtract 2 from both sides and put y in terms of x, but we can leave it as is and just say that x equals y plus 2. And that can be plugged into the original equation to be able to give us the points. We have x squared minus 2xy plus 4y plus y squared equals to 32. In place of each x, I'm going to put a y plus 2. So y plus 2 squared minus 2 times y plus 2 times y plus 4y plus y squared equals to 32. Now the y plus 2 squared means y plus 2 times y plus 2. We will need to FOIL that out. For this next part, I'm going to distribute the negative 2 and the y into the y plus 2. That will give us a negative 2y squared and a minus 4y. We then have the plus 4y and the plus y squared equals to 32. Now the negative 4y and the positive 4y can cancel, and we can also combine the negative 2y squared and the positive y squared together in our next step. So first of all, we will FOIL out y plus 2 times y plus 2. First, y times y squared. Outside, y times 2 plus 2y. Inside, 2 times y plus 2y. Last, 2 times 2, 4. We have a negative 2y squared and a positive y squared, which combined will be a negative y squared, and then all of that equals to 32. The y squareds can cancel. The two y's can combine, so we have 4y plus 4 equals to 32. Subtract 4 from both sides, so 4y equals to 28. Divide both sides by 4, so y equals to 7. We're under the condition that x equals to y plus 2. So for y equals to 7, and our condition up here of x equals y plus 2, x will equal 7 plus 2, which comes out to 9, and therefore we have the point x-coordinate 9, y-coordinate 7, where the tangent line will be vertical.